Friends, welcome to the class. Today we'll discuss some questions on probability. So let's start with the first question. The first question states, a game consists of tossing of 1 rupee coin 3 times and noting the outcome in each time. Ajay wins if all the tosses give the same result every time, that means either 3 heads or 3 tails, or else Ajay loses the game. Find the probability that Ajay will lose the game. Let H denote the head and T denote the tail of a coin. So the total possible outcomes on tossing of a coin 3 times are as follows. That means it is HHH or HHT or HTH or THH or HTT or THT or TTH or TTT. That means the total number of outcomes equals to 8. Now Ajay will lose the game if the tossing of the coin gives a different result. That means not all the heads or not all the tails. See, from the given outcomes, it is clear only in the first and in the last cases we are getting either all heads or all tails. In all other cases, it is a combination of head and tail. So the number of outcomes favorable to the given event is 8 minus 2, which is 6. Hence, probability that Ajay will lose the game is 6 by 8, or it is equals to 3 by 4. Hence, the required probability is 3 by 4. Is the answer. The next question states, one card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting the first bit a king of red color, second bit a spade, and third bit a face card. Total number of cards in a deck is 52. That means the total number of outcomes is equals to 52. Now, come to the first bit. That E1 is the event of getting a king of red color. Now, the possible outcome favorable to the given event is 2, because in red color, the king in red color are 2. Like the total number of kings in red color are 2. So the favorable outcome to the given event is 2. So the probability of getting a king of red color is 2 by 52, or it's nothing but 1 by 26. Let it is the event of getting a spade, but in a deck of 52 cards, there are 13 number of spades. So you can say the possible outcomes favorable to the given event is 13, or the probability of getting a spade is nothing but 13 by 52, or it is nothing but 1 by 4. Now let come to the third bit. Let E3 is the event of getting a face card. Now we know that the total number of face card in a deck of 52 cards is 12. So we can say the possible outcomes favorable to the given event is 12. So the probability of getting a face card is 12 by 52, or it is nothing but it is 3 by 13 is the answer. Next question. A die is thrown once. Find the probability of getting a number which is not a factor of 36. Now when a die is thrown once, the possible outcomes are 1, 2, 3, 4, 5 and 6. That means the total number of outcomes is equals to 6. Now let's do from the prime factorization 36. It is nothing but 2 into 2 into 3 into 3. Or you can say the factors of 36 in the die are 1, 2, 3, 4 and 6. That means the number which is not a factor of 36 is 5. Or you can say the number of favorable outcomes to the given event is 1. So the probability of getting a number which is not a factor of 36 is 1 by 6 is the answer. A number is selected at random from first 50 natural numbers. Find the probability that the chosen number is first bit divisible by 2 and 5, second bit divisible by 2 or 5. The number is to be selected from the first 50 natural numbers. That means the total number of outcomes is 50. Now come to the first bit. The number is divisible by 2 and 5 both. That means 2 into 5, or you can say the number which are divisible by 10 is divisible by both 2 and 5. So the numbers are 10, 20, 30, 40 and 50. So total 5 numbers, the first natural 50 numbers are divisible by 2 and 5. So the number of outcomes favorable to the given event is 5, or the required probability of the number divided by 2 and 5 is nothing but 5 by 15, or it is nothing but 1 by 10 is the answer. Now come to the second bit, number divisible by 2 or 5. That means the number divisible by 2 and by 5 minus number divisible by both 2 and 5. Now the numbers divisible by 2 is nothing but all the even numbers, which is nothing 2, 4, 6, 8 and continues up to 50, which is so total number is 25, and the number divisible by 5 are all numbers ending with 5 and 0. So it is 5, 10, 15, 20, continues up to 50, and the total numbers are 10. And from the bit 1 we got the numbers divisible by 2 and 5 both are 5. So we can say the numbers divisible by either 2 or 5 is nothing but 25 plus 10 minus 5, that is 30. So the required probability is 30 by 50, or it is nothing but 3 by 5 is the answer. The next question states, in a family of 3 children, find the probability of having at least one girl. Let B denote boy and G denote girl. So the family has 3 children, that means they may be all 3 boys, that means BBB, BBG, BGG, BGB, or GBB, or GGB, or GBG, or GGG. That means the total number of cases is 8. But out of these 8 cases, only in one case we see there will be all boys. In all other cases, there is at least one girl is there. So we can say out of the above 7 cases, in 7 possible cases, the family may have a girl child. So the number of cases equal to the given event is 7. Or the required probability is nothing but 7 by 8 is the answer. Excuse me. The next question states, number x is selected at random from the numbers 1, 2, 3 and 4, and another number y is selected at random from the numbers 1, 4, 9 and 16. Find the probability that the product x and y is less than 16. Given that x is selected from the numbers 1, 2, 3 and 4 and y is selected from the numbers 1, 4, 9 and 16, so the two numbers x and y can be chosen in 2 to the 4, or it is nothing but 16 ways. So the total number of outcomes is 16. Now product of the numbers is less than 16 only if we get the outcomes to be 1, 1 or 1, 4 or 1, 9 or 2, 1 or 2, 4 or 3, 1 or 3, 4 or 4, 1. That means the total number of outcomes favorable to the given condition is 8. So the required probability is nothing but 8 by 16, or nothing but 1 by 2. Next question. In the given figure, A, B, C and D are the centers of the 4 circles of radius 1 unit each. If a point is selected at random from the interior of a square ABCD, find the probability that the point chosen from the marked region. Let's draw the picture first. So given that the radius of each circle is 1 unit, that means this ABCD are the centers, and these and center of the circles which touch each other, and this radius is nothing but 1 unit. So we can say the side of the square is nothing but 1 plus 1, but it is 2 units. Now area of the square of ABCD is 2 square, or it is nothing but 4, because area of the square of side A is nothing but A square. Now area of the marked region, this particular region, is nothing but area of the total square minus 4 into area of any one of the quadrant, because all the 4 circles have the same radius, so we can find out area of any one quadrant into 4. So it is area of the marked region is area of the square into minus 4 into area of a quadrant, or it is nothing but 4 minus 4 into pi by 4 into 1 square, or you can see area of the marked region is 4 minus pi. So the probability or the point selected from the marked region is nothing but area of the marked region by area of the square, or it is nothing but 4 minus pi 4 divided by 4 is the answer. Next question, two dice are thrown at the same time. Find the probability that the difference of the number of the two dice is 2. When two dice are thrown simultaneously, the total number of outcomes is nothing but 6 square, it is equals to 36. Now the difference of the numbers will be 2 if we get the following outcomes. That means the outcomes may be 1, 3 or 3, 1, 2, 4 or 4, 2, 3, 5, 5, 3 or 4, 6 and 6, 4. That means the total number of outcomes should go to the given event is nothing but 8. So the required probability or probability of getting the number where difference in the numbers is 2 is 8 by 36, or it is 2 by 9 is the answer. The next question, a lot consists of 50 mobile phones, of which 42 are good, 3 having minor defects, and the remaining mobiles have major defects. BJ will buy the mobile if it is in good one, but the trader will buy if the phone does not have any major defects. A mobile is selected at random from the lot. Find the probability that the selected mobile first bit is acceptable to BJ and second bit is acceptable to the trader. Given that the lot consists of 50 mobiles, that means the total number of outcomes equals to 50. Now the first bit, BJ will buy the phone if the mobile is a good one. But how many good number of phones are there? It is nothing but 42 good number of phones are there. So we can say the number of outcomes should go to the given event is nothing but 42. So the probability that mobile is acceptable to BJ is 42 by 50, or it is not 21 by 25. Come to the second bit. A trader will buy if the mobile does not have any major defect. But how many mobiles have the major defects? It is given out of 50, 42 are in good, 3 have minor defects. That means remaining number of mobiles, or you can say 5 number of mobiles have major defects. So the total number of mobiles without any major defect is about 50 minus 5, or it is 45. So the number of outcomes should go to the given event is 45, or the probability that the mobile is acceptable to the trader is 45 by 50, which is method 9 by 10 is the answer. Three different coins are tossed together. Find the probability of getting the first one exactly 2 heads, second bit at least 2 heads, and the third one at least 2 tails. Let H denote head and T denote tail of the coin. When 3 coins are tossed together, the possible outcomes are HHH or HHT or HTT or HTH or THH or TTH or THT or TTT. That means the total number of possible outcomes is 8. Let E1 is the event of getting exactly 2 heads. Now, the total number of outcomes we go to the given event, or E1, is nothing but 3. While HHT or HTH or THH. So the probability of getting exactly 2 heads, or probability of E1, is nothing but 3 by 8 is the answer. Let's come to the second bit. At least 2 heads means either 2 heads or more, or 3 heads. So the total number of outcomes we go to the given event, or E2, is nothing but 4. Or probability of getting at least 2 heads is 4 by 8, or 1 by 2. Come to the third bit. Let E3 is the event of getting at least 2 tails. So the number of outcomes we go to the given event, or E3, is 4. So probability of getting at least 2 tails is nothing but 4 by 8, or it is 1 by 2 is the answer. There are 100 sealed envelopes in a box. 3 of them contain cash prize of ₹100, 5 of them contains cash prize of ₹50, and 10 of them contain cash prize of ₹10. Remaining envelopes are empty. All the envelopes are shuffled together and an envelope is selected at random. Find the probability that the selected envelope contains cash prize more than ₹10. That means it may contain ₹100, it may contain cash prize of ₹50. but it should be more than 10. So given that total number of envelopes is 100, that means the total outcome is equals to 100. Now, envelopes containing cash price of rupees more than 10 are rupees 8. That means the total favorable outcomes to the given event is 8. Why it is 8? Because 3 contains cash price of rupees 100 and 5 contains cash price of rupees 50. So total envelope containing cash price more than 10 is 5 plus 3, which is 8. So the required probability of selecting an envelope containing cash price more than 10 is 8 by 100, or 2 by 25. Next question. A game of chance consists of an arrow which comes to rest pointing at one of the regions 1, 2, or 3. C is the center of the circle. DC perpendicular to AB. Find the probability that arrow is resting on 3 and the second bit arrow is resting on 2. Let's draw the picture first. Now the total angle made by the center of the circle and C is 360 degree. So you can see total outcomes is equals to 360 degree. Now come to the first bit, arrow is resting on 3. Angle subtended by the region 3 is 180 degree. So the outcome favorable to the given event, that means arrow is resting on 3, is nothing but 180 degree. So the required probability or probability of arrow resting at 3 is 180 degree minus 360 degree, which is nothing but 1 by 2. Now come to the second bit, an angle subtended by region 2 is 90 degree. So the outcome favorable to the given event is 90 degree, or the probability that the arrow is resting on 2 is 90 degree by 360 degree, which is nothing but 1 by 4 is the answer. Friends, here is a few questions. Many of the questions appeared in previous board exams. So these questions will be helpful from your exam point of view. Keep practicing more and more such questions. And in case you come across any difficult question, feel free to share a question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your question. So this was for today's class. Thank you.